Hi, I'm Arjun Subedi from University of Nebraska-Lincoln. I am a PhD student, and my PhD supervisor is Professor Peter Daubin. Aim of my research is to study influence of surface and interface on bulk properties of nickel cobaltate thin films. I have carried out similar works on other members of so-called inverse spinel oxide thin films, for example, cobalt ferrite, nickel ferrite thin films. From my works on these systems, major findings so far are surface to bulk core level shifts, surface non-metal to metal phase transition, observation of intrinsic magnetic interlayer, which is different from bulk of this thin film. And in my research work, the experimental technique that I mostly use is X-ray photoelectron spectroscopy. And that technique is very surface sensitive technique. Recently, I am focusing on nickel cobaltate thin films more because it is very interesting system because it has potential application in spintonic devices, memory devices, resistive switching devices, magnetic storage devices, etc. Because it is having interesting electronic and magnetic properties. But I will be focusing on surface and interface region of these nickel cobalt thin films because interface is the device. For my work on this thin film, I have carried out several works in my own research lab at University of Nebraska-Lincoln, and I have performed some XMCD measurement at National Lab facility. For example, advanced light source at Lawrence Berkeley National Lab. For the National Lab experiment, I wrote a beamline proposal. We got the beam time, and I performed angle resolved XMCD measurement on several nickel cobaltate thin film system, and we have good results. This is obviously me describing the XMCD setup at 3.6.31 beam line at ALS. It was a good experience, but better is the fact that I came up with good results. And that's the result that I will be presenting here for the competition. Thank you so much.